Hello and welcome to the Integrated Solid Waste Management for the Smart City tutorial. I am Hari Sharma, a research scholar and a TA for this course. In this part of the tutorial, we will be discussing about the numerical that were posing a problem in the assignment as well as in the course. We will be discussing some of the questions related with the statistics, some of the problem related with the waste to energy plant, and one numerical that is related with the transportation problem. So, let us start the numerical. The very first numerical that I will be dealing with is related with the method detection limit. We receive a few of the queries in the NPTEL forum regarding the statistical problem. So, we will be discussing that problem here. Before solving the numerical, let us find out what is MDL. Small definition: the minimum concentration of a substance that can be measured and reported with 99% confidence that analyte concentration is greater than 0 and is determined from the analysis of sample in a given matrix type concentration, the analyte. So, MDL, what is MDL? Is method detection limit. MDL equals to student t test t value n minus 1, n is equal to number of sample, n minus 1 will give you degree of freedom, 1 minus alpha here is 99% confidence level into standard deviation. So, we know that n is equal to number of sample and SD is equal to standard deviation. So, to understand better, let us solve one numerical. The numerical is: calculate the method detection limit with 99% confidence level for the following sample analysis result. We are given the 8 sample ID with its value. We need to find what is the minimum concentration that it can be detected. So, sample ID and result 1, 2, 3, 4, 5, 6, 7, 8. And the value corresponding to each ID is this in mg per liter: 12.11, 12.02, 12.21, 12.06, 12.57, 12.42, 12.09, 12.32. Since to find the MDL in the formula we are given, we need to first find standard deviation. That is standard deviation. The formula for standard deviation, as we know, is the individual sample concentration minus mean of this value square number of sample, we put this in the square root. This will give you the standard deviation. So, we see this is a mean. So, we need to first find the mean. How do we find the mean? We add all these value and divide it by 8. That would be the mean value, 12.02 plus likewise to 12.39 divided by 8. That would give us the standard deviation, a mean value 12.225. So, to find the standard deviation, we put this mean value here and individual result and divided by and take the square root, we will find the standard deviation. So, SD is equal to 12.11 minus 12.225 square plus second value 12.02 minus 12.225 square, likewise up to last, divided by n. N here is 8. Total number n here is 8 and we take the square root of whole. This will give us 0.19. So, we will put this value in our first formula. MDL equals to T, n is equal to 8, we know that n is equal to 8 here, we will find 8 minus 1 minus alpha is equal to 0.99 into standard deviation, we have found 0.19. Till now it is clear, right. So, the next step is to find t value using student t test chart. So, n minus 1 is nothing but a degree of freedom, that is 8 minus 1 is equal to 7, 1 minus alpha is equal to 0.9. So, to check the value of alpha in the student t-test table, we need to find the value of alpha from here for the 99% confidence level. If we rearrange this value, the alpha value will be 0.01 into 0.19. So, how do we know value of t for degree of freedom 7 and alpha value 0.09? For that, we have a table, critical value of t distribution table, that the table will be provided, and the table will be available. If for your practice you can download the table in the internet, the table will be provided in a exam as well. If table is not provided, the value of t will be given. So, how do we calculate the t value using the table? You can see in the table, t value corresponding to degree of freedom 7, the red line, and the t value corresponding to t 0.01, where that value intersect, that intersected value would be the t student table value 2.99, here in this case 0.19. So, what do you do is, in the table you will look for alpha value corresponding to the t value, where you will see there is a lot of t value, 0t, 0.20, 0.15, 0.10, likewise t 0.9. It will depend upon the confidence level given, but for the MDL it is 99% confidence level, for which the alpha value would be 0.01, that would be related with the 0.01 t value and the degree of freedom 7. If we crisscross the value, it will be around 2.98 as far as the student t-test value. So, if you calculate this value, this value would be around t value, this value would be around 2.99 the value, and if you multiply this value, this would be around 0.57 mg per liter. So, this is the answer of MDL. So, MDL at 0.57, it indicate that this value would be minimum concentration you can trust with the 99% confidence level. This is the minimum value you can trust for the with the 99% confidence level. That would solve our MDL numerical and the problem. How do we find the t value from using the t statistical table, and how do we find the standard deviation, and we put in the MDL value, and we will find the minimum concentration that can be trusted with 99% confidence level. This is the first question that we solved. And moving on to the next question, it is related with the Hall container system. We received a lot of queries related to the Hall container system. Before solving the Hall container system, we know that collection system consists of two type of stationary container system and Hall container system. In the stationary container system, the collecting container is not moved. In the Hall container system, the collecting container itself is moved from the collecting center to the transfer station. So, let us understand what is Hall container system before solving the numerical, because the numerical involves a lot of formulas that has to be understood. Here you can see that there are number of container sites like site 1, site 2, site 3, site 4, and there is one transfer station which is manned, because this is Hall container system. This is station 1, this is this different location where containers will be there. West will be filled, the dark one will give us the filled container, and the light one is the emptied container. And this is the dispatch station, and this is the truck. The truck from the dispatch station will come to a location container location 1, and from the dispatch station it will take certain time to reach the station container 1, that would be T1, and from here it will pick, because it is a Hall container system, it will pick the container, and all the container along with the waste will be hauled to a transfer station. Here it will empty the container and that emptied container it will haul back to a station 1, and from here it will unload that emptied container and it will move to a next station. Likewise, it will do same here. It will carry that loaded container, unload in the transfer station, this is transfer station, and haul back that emptied here, and it will unload here and it will drive to a next station. It will come here, likewise. It will do to all the number of station, and from the last station it will go back to its dispatch location, where it will take another t time, because this time has to also be considered and this time has also be considered. Now, you can see while solving the numericals, we came across lot of terminologies like TH, CH, PH, CS, T1, T2, DBC, A, B, S, X. We came across a lot of terminologies while we were serving the numericals in the assignment as well. So, this is nothing but a time per trip, how much time, that time will be on hour, maximum, most of the time it has to be calculated in the hour, time per trip. This is pickup time, this is pickup time, per trip means it will carry this loaded container here, unload it here in the transport station, it will come back, that it will bring back that emptied container to a station 1, coming back and going, entire this will count as a trip 1. That means emptying one container and bringing it back to its original location, this will be counted as one trip. This is now what would be that pickup time. T1 is, as I have told you, the first value, T2 is the last value, it will go to dispatch station, and DBC is like from DBC is nothing but drive between container. Drive between the container means this value DBC. Container 1, container 2, it will unload, come here and it will drive to another container. This is a DBC value, drive between the container. A, B, S value. These are the empirical constants value that will depend on the type of truck, type of location, road, and lot of other values. This will be given either in hour per mile, hour per kilometer, it will depend. We will be solving here in hour per kilometer and hour per mile, and x is nothing but the haul distance. Now, you can see the what is haul. Haul is this value. This is called hauling. This one way is hauling. Some of the time in the numerical it is given one way haul distance or two way haul distance. If one way haul distance is given, to find the total haul distance you will multiply by 1 plus 1 2 x. So, if one way haul distance is given, you have to multiply by 2. If the two way haul distance is given, you have to use as it is. So, make sure you read the question nicely. So, with this concept, let us solve the numerical. Before solving the numerical, quick look at the table that I was talking about, A, B, C, X value. X value is nothing but, S value is nothing but a time spent in the transfer station. So, you can see for different speed limit, A value, B value changes. Speed limit can be in kilometer per hour. Also, the same value can be in the mile per hour. If mile per hour is given, you have to use the mile per hour, hour per mile in the B value also. If it is given in the kilometer per hour, you will be using B value in kilometer per hour per kilometer, same value corresponding. So, 55 if mile per hour given, that would be 88 kilometer per hour, and its corresponding value for 88 would be 0.011 hour per kilometer, not 0.018. That would ease your numerical. Let us solve the numerical. The numerical for the haul container system is: solid waste from the new industrial park is to be collected in a large container, some of which will be used in conjunction with a stationary compactor. Based on the traffic at a similar park, it is estimated that the average time to drive from the garage to a first container to the garage will be T1, that is 15 minutes, and T2 20 minutes. Remember 15 and 20 are given in minute, you have to convert this into hour respectively. If the average time required to drive between the container DBC, drive between the container means DBC, that is 6 minutes, this also you have to convert into hour. And one way haul distance that I was talking, it's given one way, not two way haul distance. You have to multiply this 25 kilometer by 2 to find the total haul distance. Is 25 kilometer, for which the speed limit is given 88 kilometer per hour. So it's 88 kilometer, 88 kmph, the value is given. So you can see in the numerical as well, pickup time formula is given PHCS, that is pickup time for whole container system. HCS means whole container system, equals to PC, that is pickup time for container, pickup of container plus unloading of container plus drive between the container, that is PHCS. And another formula that you will be using with time per trip of whole container system, this value will be an hour per trip, and THCS is time per trip per whole distance, that would be PHCS, that is nothing but this value here plus S value plus A plus Bx. The x you will be using would be tool haul distance. The A value, B value, S value, all value will be given in the numerical as well, and in the exam also it will be given. And the NT is here is equal to nothing but 1 minus W, that is off route factor, that would be given always, hour, walk hour per day, minus T1 plus T2, and if you divide this by THCS, this THCS is nothing but PHCS plus S plus A plus Bx, that is this one. So here we are given, we are provided with S value, that is this value is given, we are given A value 0.016 in the new question itself, that is this value, and the B value of 0.011, that is also given, and W, that is off route factor that you will be using here, is also given as 0.15. So here in the question you can see the first question that is asked is determine the number of container that can be emptied per day based on 8-hour work day. So number of container emptied means number of trip. How it is number of trip? One to empty the one container, it has to go to a transfer station, emptied here, and will bring back. So this number of emptied container at a one trip, that would give number of trip. So number of trip means number of container emptied. So the first question is number of container that can be emptied per day. So you can see we can use directly this formula, number of container, this is ND, is nothing but a number of trip per day, that is equal to the number of container emptied. So ND is equal to 1 minus W H minus T1 plus T2, you will divide it whole by THCS. Now you can see in the question we are provided with everything, but we are not provided with the value of THCS. To find the value of THCS, we will use PHCS plus S plus A plus Bx. But the problem again comes, we do not know the value of PHCS. So to find the value of PHCS, we have to use the formula PC plus UC plus DBC. This is nothing but pickup time, it will pick the container, it will unload the container, and it will drive between the container. This three value will give you the pickup for the whole container system. So this value is given in the numerical as, we are given as PC plus UC equals to 0.4. It is given in the numerical in the second row 0.4 plus DBC in the numerical, it is given drive between the container is 6 minutes, that you have to convert into hour, that would be 0.4 plus 0.1, that would be 0.5 hour per trip. So we found PHCS. Now we can use this value here to find the value of THCS. So let's find what is THCS. THCS equals to PHCS plus S value is given 0.133 plus A value is given 0.016 plus B value is given 0.011 into one way haul distance is given, that is 25 kilometer. So, for the two way it has to be 2 into 25. So, PHCS, this value we found it here, that is 0.5 plus 0.133 plus 0.016 and 0.011 into 50. If we calculate this value, we will get 1.20 hour per trip. So, we found the value of THCS by using PHCS, and now we have to put all this value here. Before that, let us find the value of T1 and T2, which is given as 15 minute and 20 minute. That has to be converted into hour. So, 15 minute would be that would be 0.25 hour, and that would be 0.33 hour. So, we know the value of W, that is given, we know the value of H, 8 hour, that is given in the question. In the first question given 8 hour walk day. So, we will put all this value and find out what is the number of container in it. So, MD is equal to 1 minus W H minus T1 plus T2 by THCS. 1 minus W is 0.15, H is equal to 8 hour minus T1 is equal to 0.25 plus 0.33. THCS we have just found, that is 1.20, and if we calculate this value, it would be 5.18 trip per day. So, you say per day it will do 5 trip. That would solve our first part of the question. In the second part of the question, we are told to find, using this value, find the actual walk day length. So, actual walk day length, we are being asked to find the value of H here. Initially we were knowing all this value and we found this value. Now we know this value, and now they ask us to find the value of H. So, just rearrange this value, it is like more like proving the value that H is equal to near to 8 hour, that is given in the first question. So, rearrange this value, that the rearranging this will just give us ND we will directly put here, ND is equal to 5, 1 minus W, and the H we have to find, T1 and T2 is same value, and THCS is also for same value. So, you will just find the value of 1 minus W into H minus 0.25 plus 0.33 equals to 5 into 1.20, and if you rearrange this value, the H would be around 7.74 hour. You can see that 7.74 hour is almost near to 8 hour. So, the value given in the questions was 8 hour. We found everything for the 8 hour, and by using whatever we found, when we back check, we found the 8 working hour is almost near to 8 hour. So, it solves our first transportation question related to the haul container system. Likewise, there you can solve other numerical as well. In the last part of the tutorial, we will be using the waste to energy numerical that is related with the pyrolysis. The question is, the car company has signed collaboration with the waste management consultancy to design a pyrolysis unit for the management of car tire in Kolkata city. It is estimated that annually 9,000 tires could be treated. The mass of a tire of one tire is 12 kg. Based on the preliminary investigation, it is estimated that 31% by mass of car can be converted into carbon and 26% by mass can be converted into gas. What is predominantly methane? That gas is methane. The first question that we are being asked is determine the mass and the volume of the methane. So, let us solve the question. the number of tires then we are given in the question, number of tire is equal to 90,000 and the weight of one tire equals to 12 kg. So, mass of the total tire we will calculate in gram, mass of the tire, mass of 90,000 tires equals to 90,000 into individual tire weight is 12 into 1 kg equals to 1000 gram, that would give us 1.08 into 10 to the power minus 9 gram. In the numerical, it is said that we are concerned with only the methane, 26% can be converted into gas. So, we can say of mass 26% by mass can be converted. So, this is a mass. So, of this 26% can be converted. So, the 26% by mass means that would be 26 into 1.08 into 10 to the power 9 divided by 100, that would give us around 2.80 into 10 to the power 8 gram of CH4. So, this will solve our first part of the question, that we were asked determine the mass of the gas generated. So, the next question here would be volume we have to calculate. So, to find the volume, determine the volume in the standard temperature pressure, and also in the determine the volume at 30 degrees Celsius we have to find. So, to solve the second part, we know that molecular mass of methane is equal to 16. So, therefore, moles of methane we know that it is mass by molar mass. That would give us around, if we just put the value what is mass that we have calculated and what is molar mass, we know that 16. So, value if we just put the value 2.80, that is mass in 20 into 1.08, that 16 is molar mass, and if we have to just put the value, this is not 2.6, this is 26. This value is 1.755 into 10 to the power 7. You can see that we have just put in this value here and divided by molar mass, that is 16. So, this is the number of moles, this is number of moles of methane gas. So, we know by standard value that 1 mole occupies 22.4 decimeter cube volume, and that is at STP, standard temperature pressure, that is 0 degree Celsius, and the standard temperature pressure, if you are talking the temperature, is at STP. Hence, we know the volume of 1 mole and we know the number of mole. So, hence the total volume would be number of mole 1.755 into 10 to the power 7 into 22.4 decimeter cube. If we just multiply this value, that would be 3.93 into 10 to the power 8 decimeter cube, and since 1 meter cube equals to 1000 decimeter cube, if you convert this into the meter cube, we will give 3.93 into 10 to the power 5 meter cube. So, you can see this value, this is in STP, but in the question we have also been told at 30 degrees Celsius we have to determine the volume of methane produced at 30 degrees Celsius. So, we know the relationship between the volume and temperature is explained by the Charles law that explains the relation between the volume and the temperature of gas. That explain the relationship is something V1 by T1 equals to V2 by T2. So, we know the volume V, just we calculate, we know the standard temperature, pressure, temperature, we know that. We have to find the value of V2 at 30 degrees Celsius, it is also given. So, if we just put this value, rearrange the value, we would get V2 is equal to V1 T1 into T2. So, V1 we have calculated 3.93, from here 3.93 into 10 to power 5. T1 is the temperature, standard temperature, pressure, and at Kelvin it is 273 degree 273 degree Kelvin in the standard temperature, pressure, and T2 is, at question been asked that T2 is 30 degree Celsius, that would be 273 plus 30, this is Kelvin, we are converting degree Celsius into Kelvin. So, 3.93 into 10 to the power 5, 273 into 303, this would give us 4.36 into 10 to the power 5 meter cube. So, the second part of the question was determine the volume of methane produced in this process at 30 degrees Celsius. So, we found it 4.36 into 10 to the power 5, and the first part where we were asked to find the mass of the methane if from the pyrolysis process, the mass of the methane is this and the volume is this. So, we generally solve the three question. We generally solve the three question in this part of the tutorial. The first question was related with the MDL, second was related with the Hall container system, that is transportation of the waste collected, and the third was related with the waste to energy part. Thank you for joining on to this part of the tutorial. Hope you enjoy. Thank you.